So now we will analyze the same spectrum, but using the reference, the gold reference taken from a pure gold sample. So that's here, that's the recorded spectrum. It's fairly clean, there's a small amount of carbon. So we correct this for the analyzed transmission function as we did before, use e to the minus 0.7. We have that corrected spectrum here. Now we isolate the peaks. We use the mouse to cut out the region around the gold 4D and put in a background line. We fit it out here like this. So we fit the slope out in this range here first, and then we move it in here and subtract it, and we have a reference now, gold 4D reference. Save it, and we have the reference up here. So we cancel to go back to the main menu. We analyze gold 4D reference. We put in the value for the IMFP 13.5. We analyze this buried layer, and we expect this to be pure gold. So I put in 3 or 4 nines here, and sure enough, it's very nice. And we can just save this spectrum. So this is now the background corrected spectrum, the green one. So this has been corrected for the transport through the material. So in principle, the green spectrum here corresponds to the spectrum from a single atom of gold. So we can compare that to the spectrum we determined when we analyze the unknown sample, where we should get exactly the same after correction. So we save this, we just use the default file name. So this is the reference spectrum, this is the analyzed with the extension ANL of that one. So we can go back to the gold 4D and we can analyze that. We put in 20 here and we see that it is a thin layer on top. We have about 15 and 150 height for the two islands. And the coverage, the relative coverage is here. So we now overlay this green one here with what we have determined in the reference spectrum. To do that, we change the way we plot the spectrum from output plus input. Output is the green one, input is the black one. So we change that to output plus scaled reference. So it tells me here in this window what to do. First, as you click OK, then as you click the reference spectrum in the file list. So I do that, click OK. The reference spectrum is here. And they line up very nicely. The fit is very good. The scale factor is off. So what this means is that the intensity in one of these is larger than the other one, but the fit is very good. So we have the right depth distribution of the atoms, but we don't have the correct coverage. So we should multiply we want the scale factor. The scale factor is calculated by the area. The software calculates the area of these two curves between these two lines here. And this scale factor is the ratio of these two. So the ratio should be 1 and the shape should be the same. The shape is fine. We need the scale factor to become 1 here. To do that, we need to increase the coverage of each of these two by this factor here. So that'll be about 2.5 here, and here it will be it'll be 2, it'll be about 70, wouldn't it? We can see it here. Now we're there, right? 70, exactly. 65 or 70, that gives a factor of 1. You can fine adjust this, of course. a little bit. So this determines what the distribution is. We have these two islands. The tall islands of 150 angstroms cover 25% of the surface. The small islands of 15 angstroms height cover 65% of the surface.